any whole number. If I write a general form, so it's a plus b raised to the power n, and n is any whole number. N is any whole number that we are going to study in class 11. Right? Now, see, binomial is the combination of two monomials. Okay? Binomial is the combination of two monomials. So suppose if I am writing a plus a raised to the power 2, this is not a binomial. This is not a binomial because this I can write 2a whole square. Right? So this is a monomial only. This is a monomial. This is a monomial. So binomial is two different terms. Binomial means two different terms. We should take two different terms. So that makes a binomial. Now there are very interesting facts when we do the expansion of these binomial terms. Let's see the interesting facts about binomial terms. Okay, let's start from here. A plus b raised to the power 0. A plus b raised to the power 1. A plus b whole raised to the power 2. A plus b whole raised to the power 3. A plus b raised to the power 4. Okay, let's go up to 4. Then we can generalize. A plus b raised to the power 0 is obviously 1. Any base raised to the power 0 is 1. Then this is going to be a plus b. And this is a square plus 2ab plus b square. This is a square plus 3a square b plus 3ab square plus b cube. Right? This is a4 plus 6a cube b plus sorry, this is 4. This is 6a square b square, and this is 4ab cube, and then I'll get b4. Okay. Now see, there are few interesting facts about this. Here, what is the index here? 0. And how many terms you got? 1. What is the index here? 1. How many terms we got? 2. Let's view. Let's see few more. Here index is 2. How many terms we got? 3. Here index is 3. And how many terms we have? 4. And here also index is 4 and terms are 5. So what does it mean? If whatever is the index, number of terms is 1 more than the index. So we'll just write here, summarize here. Number of terms in binomial expansion is 1 more than the index. Right? This is one important derivation that we have seen. Now next, you see, if you observe coefficient of the end terms, leave this one because only 2 terms are there. Look here, this one. Coefficient of the end terms are same. See? Coefficient of the end terms are same. Here also, and here also you can observe. So this is index. Coefficients of end terms is 1. Right? At the beginning also and at the end also. 1. Now see one more thing. Power of this is 1, this is 1. If you add these two, you will get 2. And here also it is 2. That means power of each term is same as the index. Right? And if you observe here you observe it is 3 and here it is 2 plus 1, 3. Here also if you observe it is 1 plus 2, 3. Here it is b cube. Here also it is 3. So if you observe power of each term is same as the index. Right? Power of each term is same as the index. Now with these things you can write down any expansion. If I ask you children, please write down a plus b whole raised to the power 10. Okay? So very easily you can write a raised to the power 10 plus a9 b plus a8 b square plus a7 b3, and you can go on writing, and the last one will be b raised to the power 10. Okay? This you have written, but one very important thing is about the coefficients. How we are going to write down the coefficient? Is it following any pattern or is it following any rule by which we can find out these coefficients? Yes. These coefficients also follow a certain rule that is very interesting, right? And see, this binomial theorem is given by Sir Isaac Newton. Newton Baba has given this binomial theorem. It's a very interesting binomial theorem, very interesting facts about binomial theorem, very important observations of binomial theorem. Okay. Now we'll study how to find out the coefficients. How to find out these coefficients. All these coefficients. How to find out this. Right? So if you are able to find out how to write down these coefficients, then we are able to write down any expansion. Okay? So these coefficients are written by using Pascal's triangle. Pascal's triangle. Okay. So let's form a triangle. It's not the regular geometry triangle that you have studied. It's the triangle of numbers. Very special numbers. Now, write 1 here at the center. Then write 1 here, 1 here. Okay. Then write 1, 2, 1. Okay. Then 1, 3, 3, 1. I'll rub this so that I have sufficient space to write down. See. Now this is 3ab square minus bq. Now here if you observe, it is the sign is alternate. Positive and negative signs are alternate. This is positive, this is negative, then again a positive, then again a negative sign. Right? Okay. So let's try out writing expansion of a minus b raised to the power 5. Because I hope you have not written till now. This is the first time we are writing. Okay, without multiplying, like a minus b whole cube into a minus b whole square, that we are not doing. We are directly writing down the binomial expansion of a minus b raised to the power 5. As I told you, first term, so it will be a raised to the power 5. Okay. Now see, this is for power 2. These are the coefficient for power 1. These are the coefficient for power 2. This is for 3. This is for 4. And this one is for 5. Now, looking at the triangle, you can write down the coefficient. The first is 1, a raised to the power 5. Next, we'll have a minus sign because I said we'll have alternate plus minus sign, negative sign. Coefficient will be 5. Power of a will be reduced. It will be a4. Power of b will increase. So it will become b. Then a positive sign. Coefficient will be 10. Right? Now power of a will be 3 and b will be 2. Then a negative sign. Then again a 10. A square b5. Then we'll have 5 a b. Sorry, something wrong I have done here. It should be 3. It should be 3. Okay, 3. Then here we'll have 4 and then negative sign. We'll have b raised to the power 5. Okay. Now let's observe all the things that we have learned till now. A minus b raised to the power 5. R is 5. So number of terms should be 6. 5 is even and number of terms is 6. So it is, so 5 is odd. Number of terms will be even. So 1, 2, 3, 4, 5, 6. So we have 6 terms. Right? Now let's check out the power of each term. See, first one is 5, then it is a4, 5, then a cube b square, again it is 5, a square b cube is 5, ab raised to 4 is 5 and b is also 5. Now see, a raised to 5, here we have a raised to 4, a cube, a square, a, and power of b is increasing, b square, b cube, b raised to the power 4 and b raised to the power 5. I hope this is clear to everyone, and now everyone will be able to write any expansion of any power, right? But still we have one more difficulty. These are okay, up to 5, up to 6 is easy to write. Now what about if I ask you to write till a plus b raised to the power 20? A plus b raised to the power 20. Will you be able to write down the expansion of this? It will become, certainly it's difficult because triangle also we have to draw up to that. So we have a formula for writing down such type of bigger index expansion. That we will be taking in the next class. Revise all